Fellow engineers, welcome. By the end of this video, I want you to understand LangChain to the point where you know if you should or shouldn't be using LangChain to build your agentic software. In this video, I'm going to share key features of LangChain. We're going to talk about strengths, weaknesses, and I'll give my raw, unfiltered opinion of LangChain based on my decade of experience building software. My name's Dan, I go by Indie Dev Dan, and I took this deep dive into LangChain, so you don't have to unless it's actually valuable for you. Let's dive in. So I want to answer this question for you guys. LangChain, why is this useful? Here's a general outline of everything we're going to go through. We're going to blaze through these. What I want to give you is the high-level idea of what LangChain can do for you. Skip ahead at your own risk. These ideas do compound on each other. At the very end, I'm going to give a summary of why you should use LangChain and why you should not use LangChain. Why would I use LangChain instead of just querying OpenAI or whatever LLM provider that I'm using? So this is actually pretty slick. You can get set up with your LLM in 3 lines of code. No API requests, no handling errors, no anything like that. It just works. I've queried OpenAI. You can do that with a single and a multiple response format. So as you can see, we got the results returned. You can see here, this is the LLM model. So this is the base model. This is text eventually, right? This is not GPT Turbo. This is not a chat model. Another feature of LangChain is that they have async support out of the box. Right? When this runs, it runs async and it fires off all of these LLM queries at the same time. Another super useful feature, oftentimes you don't need to keep requerying. You really want to reuse your results. So you can set up this LLM cache and reuse the results. So as you can see here with the maxed out temperature, we're going to get different results every time. But since we're using the LLM cache, this string has already been cached. Pretty useful. This is going to keep your costs lower when you need to requery. All right. So, another solid feature. So far, so good, right? Potentially useful things. You can serialize, and of course you can track your token usage. So let's talk about the chat model, right? So their chat interface definitely feels a little verbose, but it also feels clean and simple. So, as you can see, we're setting up the OpenAI chat. We're setting up our messages. We have a system message, which describes the top level functionality of the LLM. And then we have the human message, which is, just you querying the LLM. So pretty good. And then we can dump the response down here. So I'm asking if I should quit my job and pursue my business full time, to my AI chat that is a elite product manager, and giving some pretty solid advice, telling me that I should validate my product or service, have a clear path to revenue, then it might be worth considering. The chat OpenAI model interface does use GPT 3.5 Turbo out of the box, which is great. Reusable chat prompt templates. So if you've done any amount of work with LLMs, you know that generating the right prompt and templating your prompt is a lot of where the magic happens. Let's be honest. LLMs are all about communicating via language. So prompting is super important. I found that the LangChain API for prompting and templating is just a bit verbose. Like, why do I need to build all these intermediate classes? It's just string templating. And this is a theme that you'll see, I think, as we move forward. One of the big critiques of LangChain is that it's just string templating. This is kind of true. This is also not true. It'll make sense as we proceed. But as you can see, Helpful Assistant is going to help us convert English to Spanish. We're going to pass in the text, and these variables get properly filled in to our system and human template. So that's chat-based templating. There are simpler ways to do this, which we'll show off in a second here. Other things that could be useful with the chat models, there is streaming support. So if we hop over to LangChain here, you can stream back the entire response, so you can get that real live interface type experience. Nice to have. I know some people really want this and don't want to build it themselves, so this could be useful for you. And of course, we get our token usage. That's kind of expected. Let's move on to text embeddings. All right, so this is kind of one of the big interesting features. text embeddings really are taking center stage right now in the AI world, and I'm not sure that's the right path to go down. It makes sense. It helps us compare information and then generate responses, but just focusing on LangChain, it's a really, really, really clean, really simple implementation, right? So just 3 lines. I've got my OpenAI embeddings, I've got my text, and I'm embedding my text, right? This is kind of the dream, right? You have your function and you have your content and you have your response, right? And in all perfect cases, all perfect scenarios, this is how software works everywhere. As you can see, our response is a big vector with, our text spread out against dimensions so that it can be compared against other text. Good stuff here, really simple. So let's talk about prompts some more. A lot of what you're going to be doing with LLMs is creating templates and replacing the templates. So LangChain has really taken note of this and have built some pretty solid tooling around it. So you can see here, I'm actually saving and reloading this prompt into this naming consultant prompt.json. So we can open that up, naming consultant prompt.json. As you can see, we've created a serialized JSON response, right? So you can imagine you have a bunch of these prompts stored, wherever you might store them, and you can reuse them based on whatever condition needs to be met. So, we then reload the prompt from the file, and then we do our prompt templating, then we query. We're building a AI product that generates software automatically. So we get, auto gen AI. And if I go ahead and rerun this, we're going to get auto build AI or code craft AI. It's weird that this is just string templating, or it's kind of silly that this is just string templating. And there seem to be 2 different prompt templates, one for chat and one for LLM. Again, I wish LLM providers would just smash these together. I know there are reasons for it, but this is kind of useful. You can provide few shot examples. As you know, sometimes it's helpful to provide examples to your LLM. This helps the LLM create more accurate responses. So kind of useful. Depends on your use case. Let's talk about indexes, right? So this is, like I said, for better or for worse, the center of a lot of AI work right now. You have a large corpus of data, and you embed that data, and then you query against that data using similarity search. LangChain has realized this and created some pretty sophisticated tooling around it that solves the common problems surrounding embeddings. Right, so a couple cool things right at the back. We have the text loader, we have documents, we have the text splitter. So this is definitely not a simple problem, and it is great that they have an interface to automatically split text for you. There are big problems here with losing context of the chunk that you're chunking when you have a large corpus of data, and they have a single class with a single function that splits this into documents for you. That's fantastic. I'm using Chroma DB as a local open source embeddings database just to keep things simple. Using OpenAI embeddings, building up the database, you pass in your row and you pass in your embedder. And then you can see here, I have skateboardingtricks.txt that's getting chunked. And then I'm asking what tricks require a 360 rotation. And then I'm doing the DB similarity search and getting all of the responses. So as you can see here, it did a decent job. It's picking up, 360, hard flip 360, ollie heel flip, 360 ollie kick flip, 360 pop shove it. But then it's got some bad results in here, right? Like these are chunked by documents, so it's just returning the entire documents, but air, grab, bowl, and ramp. This is more of a problem of me not chunking properly, but the point is made. You can do embeddings and similarity search very quickly. I mean, what do we have here? Maybe 10, 11 lines of code. Super useful. Let's go ahead and move on. So when it comes to indexing and running question answer on your embedded documents, LangChain provides a really clean, really simple way to do that. There's a bunch of magic happening here under the hood. Definitely check out the documentation if you want to learn more about that. But in even fewer lines, we have a index to quickly respond to our query. And so now I'm saying list all frontside 180 tricks, And as you can see here, the frontside 180 tricks are frontside 180, nollie frontside 180, switch frontside 180. So it looks like it got all of them. And just to show off the skateboarding tricks, it's just a list of all, a ton of skateboarding tricks. It's important to differentiate between querying on your data and running similarity search, right? Similarity search is a lot more generic. It's just going to give you back things that seem related to the text that you've written in your query. Whereas full-on LLM querying is going to allow you to ask questions about your data. LangChain provides a great way to accomplish that. All right, so this is one of the areas I think LangChain really shines. You can load data from basically anywhere. In this example, I am loading data from a CSV file, and they also have a Notion database table loader, which is pretty fantastic. I found that this was kind of slow, not sure what's up with that, but just to list a few more: Zero CSV, data frame, email, Figma, Drive, Hacker News. We have Notion, HTML, images. You can pull in images, YouTube, Word docs. They have a really, really great library of document loaders. And so why is this useful? A lot of what's going to differentiate LLMs is what data is it being queried against, right? We all have that data set up to, September 2021, whenever the cutoff period is. That's not special. What's special is what data set can you give your LLM? And LangChain helps give you a bunch of out-of-the-box loaders to quickly load your data from many, many common sources. There's S3 in here. A lot of people are going to just go right for S3, of course, right? The documents were loaded. There's definitely better ways to format this, but you can see here, here's the data set, right? So home, price, square footage, bedroom. And if we hop back, we have home, price, square footage, bedroom. So that's all great. All right, so let's look at another example. There's this idea of vector store retrievers, which is what I was showing off in the first example, where you can write away a query on your documents, right? So we have get relevant documents, query, and run similarity search on your documents. I'm printing out the page one by one, and I'm loading using the HN document loader, so Hacker News document loader, and this is the post topic, right? So ChatGPT outperforms physicians in quality empathetic answers to patients. Good stuff. I'm trimming some of the comments off because I don't need all that. No, it's just to save space from the to save space and expenses from the embeddings here, right? So just don't need to run that. And then you can see here, I'm saying, what's the worst case scenario of AI outperforming physicians? So we get some of the, ideas with negative sentiment on ChatGPT outperforming physicians here based on that query. That's pretty powerful. Again, I want to highlight the out-of-the-box loader in just 2 lines. We have data from this source. One of the big things I look at, and I'm sure that you look at this too when you're looking at new tools, is how fast will it allow me to go? How much BS boilerplate do I need to set up and work through? How many times am I going to have to code a wrapper around some endpoint, some variety of endpoints? Beautiful solution to that, and it's going to save you a ton of time. One more thing I want to highlight here with indexes, there are different options for text splitting. Check that out if you're interested. Let's talk about chains. Up till now, we have been talking about models, prompts, and indexes. Now, chains are where things get interesting. This is where we start putting things together. Chains chain together links, which can be primitives or other chains. Primitives include prompts, models, and arbitrary functions, okay? So that's really important. The big question when I was using LangChain is what's a chain? What are the components of a chain? Why is it called LangChain? After you watch this section, it's gonna make sense. So what is a chain? Here is a chain. So in this example here, we have provided an LLM and we have provided a prompt, and we're saying verbose. So we're saying, be detailed, tell me everything that's happening. As before, we have a prompt template. What's a good name for a programming language that focuses on attribute? I'm going to focus on the fast performance, and then we're printing that out. So this is using the OpenAI LLM. Should not have called this chat. That is wrong. So let's go ahead and fix that quick. And down here, we are running the exact same version using chat. So the output for this looks like this, right? So we have the LLM and we have the chat version. We got light speed code and we have rapid code. So that's not really important. It's kind of doing what we've already done. But the key here is that we're now building these out in chains. And chains are going to be useful as we move on. So let's go ahead and look at some more use cases of chains. This is pretty huge. When I saw this, I kind of like had a, okay, this makes sense moment, right? Kind of the light bulb moment. So with chains, you can create sequential chains of prompts. So what does that mean? Let's look at an example, right? What's a good name for a new programming language that focuses on attribute? That's prompt. We create a chat, and then we create this chat chain, right? Second prompt, write a catchphrase for the following programming language. Okay, so now you can see how this is going to start tying in together. So that's second prompt. So then we set up our chat chain 2. Now we have the overall chain that wraps together both chain 1 and chain 2. Funny how I use the number and the letters here, whatever. And now I'm running just on the first prompt. And as you can see, what's a good name for a new programming language that focuses on speed? Swift flow. And now, catchphrase, let your code flow with swift flow. Okay, so, small example, simple example, but this is powerful. Why is this powerful? When you think about a problem, you don't just think about the first answer to the first step, right? Like say you want to set up a new server. There are 50 decisions you need to make, 50 questions you need to answer along that. You are actually creating a chain of thought when you're going through that process of thinking about how to do something complex. Simple sequential chain gives you that ability to tell your LLM the steps it needs to run. It gives it the power to solve more than just one problem and chain together reasoning, just like you or I would when we're thinking about solving a problem. That is a big deal. We're chaining prompts together. We're building a network of question answer nodes. Some other notable things about chains, you can build your own custom chain class. So maybe you want to, clean up the responses in between. Maybe you want to, run arbitrary functions between chains or wrap the chains in some new class. You have all that ability. You can do all that. We have chain serialization, and then we have the transformation chain. So with the transformation chain, you can run custom functions on your input and output of the chains. All useful stuff. Let's talk about memory. Why is memory useful? Why do you need to give your AI memory? Well, memory is really the foundation of making good judgment. What does that mean? So I know that this gets kind of philosophical, but that's where we're at with LLMs and artificial intelligence. What is memory? Memory is experience. Memory is skill. Memory is an understanding of things that have come before, which gives you the ability to alter the future, to make better decisions. AI without memory is not that useful. It doesn't really matter how well it can respond to one thing. If it doesn't remember the past, if it doesn't understand your problem with your data, it's not useful. That's why we need to give our AI memory. Memory is knowledge. Memory is experience. Memory is skill. So let's look into how LangChain provides your AI with memory. LangChain has several different types of memory and several different ways to incorporate memory. Let's use one of the simplest ones, right? So just like in the ChatGPT interface, you have question and answering, right? So here, I'm setting up a chain. Notice how we're reusing the chain concept, right? We're chaining together an LLM, and now we're chaining together memory, okay? Now, what I'm going to do is, before I even prompt, I'm going to say memory save context. I'm going to give it information, input and output. So this is like a conversation that we haven't had yet, but it will have knowledge of, right? So here's me with a query. What are the top 3 programming languages? And here's the AI responding: Python, JavaScript, Java. And now I'm saying, explain your ranking. So there's no way to answer this unless you have some type of memory of something that we just ranked. The AI starts responding with the ranking. It's explaining the ranking. It's explaining why Python is first, JavaScript for web dev, of course, and then Java. There it is. We just gave our AI some memory. Of course, this is really simple memory. there are several memory integrations. SQL, Redis, vector stores, of course, are the most popular, raw memory, and then more. There are tons of ways to do this. I just want to nail home the concept that without memory, your AI is not that useful. It needs context of your problem. Okay, so a couple other things. There's entity memory. We have custom memory classes, so you can build out your own memory classes. LangChain is really great about providing custom interfaces. Then we have multiple memory sources in the exact same chain. All right, so agents. This is where everything comes together. Using LangChain, this is how you create agentic software. We have to talk about the big bag of tools that LangChain provides out of the box. What do I mean by that? Here you can see in 4 lines of code, I am running a DuckDuckGo search that answers the question, what's the current time in UTC? Now, similarly to our chain, we have passed in a tool with our LLM with the agent type, and we're saying be verbose. So you can see here, thanks to the verbose flag, the agent thinking, I don't know the current time in UTC, therefore I need to search for it. Action, DuckDuckGo search, action input, current time UTC. It gets a response back, and then based on the results, it's returning the final answer. Now my agent has access to essentially a search engine. And there are, of course, you can use Google search, you can use Bing. This array here is really magical. Why is it magical? Because you can give it several tools, and then it will decide which tool is the best for the job. There's a lot of work, I think, to be done here. It isn't perfect. When you give an agent a tool and a problem, now we are down the path of creating agentic software that does things on your behalf automatically. Here's another example of an agent with several tools. This is where things get really interesting. So I instantiated a shell tool provided by LangChain, and I created a prompt. Then I created a custom tool. It's very likely that you'll have several custom tools, and I just created a simple logging service, and you need to describe it for the agent so it understands when it should use your tool. And then you need to create a function that accepts input and does some work. In this case, I'm just passing in a Lambda function that just prints special logging service and then dumps whatever comes in. I'm formatting the description a little bit. This is right from that line's from the LangChain docs, and then I'm initializing our agent. And as you can see here, I'm passing in both tools. I'm passing in our LLM. I'm specifying the agent type. There are several different agent types that you can use. Passing in the prompt, and then I'm saying verbose true. So notice how this is a lot like the chain functionality. Let's look at my prompt here. Read all files in the current directory and report the attribute. Then log the results. The attribute I'm saying is created date plus file name. And then I'm running self-ask with search. Right, so that's just the agent. I'm basically saying, agent, run this. And let's look at the output. You can see it working through this. So what is the task? Thanks to the shell tool, it's running this shell command, right? And now it's making an observation based on the response. You can see it ran ls-l. And now that it's done that, it is automatically, because I asked it to log the results here, you can see that it is thinking, okay, I need to log the results. So let me take that action and run the logging service, which is the name of this tool here. So it's running the logging service. And as you can see, the output is special logging service, list of files in the current directory with their created date. And bam, that is the output that comes out thanks to the tools, thanks to the prompt, and thanks to the agent. You can start to see it all comes together here. One of the last big concepts here as we wrap, we have toolkit agents. So what is a toolkit agent? So a toolkit agent is a set of tools that are operated by an agent. So you can see here we have a CSV agent, which is answering the following queries. How many rows are there? And what's the difference between the cheapest and the most expensive home? So we have this home prices.csv. We can pass that into our CSV agent. So you can think of the toolkit agents as higher level abstraction, wrapping agents and tools. We have 128, and you can see here it's using a Python tool, write Python code, and determine the response of the highest price minus the lowest price. It's using whatever tool it needs to solve the problem. In this case, it looks like it just used the Python tool. Okay. And, maybe useful. There are different agent types, and you can define your own custom agent types. The agent types use the LLM to determine what tools and what actions they need to take. What's the summary of all this? So there are two ways to look at LangChain. The first approach is LangChain is stupid. It's just a bunch of wrapper classes around string templating. I think that thinking about LangChain like this is not incorrect, but it is not doing it justice. There are tons of other out-of-the-box, super useful features, like the document loaders, like the agent tools, like some of the pre-built agentic tool sets, as they call them, are quite incredible and help you get up and running quickly. A lot of what LangChain is doing is just string templating, unfortunately, maybe 70%, but the other 30% in combination with the 70% is super, super powerful, super powerful. So that brings us to the second way to look at LangChain, right? LangChain is amazing. It's a massive open source tool set for building complex AI pipelines. What are we all saying there? What are we all trying to get? We're trying to build agentic software. What is agentic software? I keep saying this. What is agentic software? Agentic software is a software agent that solves problems on your behalf without your intervention. If you take that and extrapolate it, there are massive, massive gains to be had by building the right agentic software. If LangChain is that tool to help us build agentic software, we need to be learning it and mastering it and using it. So let's break down the cases in which you should use LangChain and when you should not. You should use LangChain if you want speed, customizability, and versatility in your LLM development. As you saw, there are lots of 3, 4, 5 line, quick setup, quick execution interfaces to get up and running. Okay. You should use LangChain if you want LLM optionality. The list of models that LangChain supports is pretty sizable. I think they're really, really great about not locking you in to a single model provider. And that's what you don't want. If you build your interface in a raw way where you're building like an open AI module, you're locked in, right? That is an example of lock-in. To be fair, it's not a ton of work to switch out, but why even go down that path when you have a framework to allow you to switch out of that LLM automatically with just a single class? If you want out-of-the-box data loaders and indexers, the out-of-the-box tools that LangChain provides to me is the biggest reason to use LangChain. One of the biggest reasons to use LangChain. It's going to save you time. It's going to help you not write more boilerplate code that has already been written by hundreds of engineers. And lastly, if you want your AI to have memory, then you absolutely should be looking at a tool like LangChain. Like I mentioned, memory is experience, memory is skill, memory is context. The AIs that will win are going to have interesting data sets, right? They're going to have interesting memory formatted the right way so that their LLM can access it when it needs it, if it needs it. I also want to highlight the agents and the tools. They are very powerful. You can get up and running very quickly. Let's get to the negative, right? So when would you not use LangChain? You should not use LangChain if you don't have time to learn a new API. There are a bunch of classes here. There are a bunch of new interfaces, a bunch of new parameters that you're just going to have to take time to learn. You should not use LangChain if you don't have complex use cases and only need a few prompts. I would say in that case, just do the string templating by yourself. Put any memory or context that you need in a string template, especially if you're using GPT-4. Like, don't bother with this. It's going to burn more time than it's going to help if your use cases are simple. And I think that LangChain actually says this in the documentation. This isn't for simple use cases, right? All right, so if you don't believe LLMs are the future of AI, then you should probably not use LangChain. I think that there's a big assumption going around right now that LLMs are like the thing that's going to be the future of AI. It seems like they are. It seems pretty promising. I'd probably bet 65% of the farm on that, but that leaves 35% of us just burning time here on LLMs. So that's definitely a personal decision. If you don't believe LLMs are it, don't use time learning LangChain, which is basically a giant wrapper around LLMs. If you don't need memory in your AI, then I don't really think that you want this. LangChain isn't going to be that useful. That's one of the big selling points of LangChain and other libraries. They help you interface with memories. They help you interface with vector databases, vector stores. They help you load data And a lot of that is all to give your AI memory. If you don't need memory, you probably don't need LangChain. Build a small string templating class, build a, YAML file or JSON file with your list of prompts with templating, and you're good to go. Really, you're good to go. That's my summary. I am bullish. If you're playing poker, I would raise on LangChain. I think that it is great software. I am going to be using LangChain in my development and my efforts to build agents that solve problems alongside and for me automatically. So that's my take on LangChain. I definitely want to know what you think. Huge thanks for watching. I thought this was going to be a shorter video, but here we are. Hopefully I can cut this down and really compress it for you guys. But thanks for watching. Subscribe and like for more deep dives into new AI tools without having to take the deep dive yourself. Let me do the deep diving for you guys. Let me save you some time. I know what it's like to see a new freaking GPT-X software, XYZ. It's exciting. It's also really annoying. It's impossible to keep up. So thanks for taking the time. I hope this was helpful. I hope you have a better idea of if you should use LangChain. I'll see you guys in the next one.